Okay, this lesson is lesson 4.1.4. It's more about the tangent ratio, right? So let's continue. It says the Leaning Tower of Pisa is expected to collapse, so it's going to fall down once its angle of slant is less than 83 degrees. Currently, the top of the 7th story, point A in the picture here, is 50 meters above the ground. When a weight is dropped from point A, it lands 5 meters from the base of the tower. So if we zoom in here, you see that this is point A. You drop a rock down, and that rock is 5 meters away from that, from the base. All right. So what is the slope ratio for the tower? So this is the angle we're looking at, right? Angle of slant. You see the little arrow there. It's a little hard to see. And our angle we're looking for the rise over the run, right? So our slope ratio is going to be 50 over 5, which is 10. This is our slope ratio, 10 over 1. Okay, so now you have to refer back to your notes, your chart from lesson 4.1.3. It has the tangent ratio chart, and look it up, right? Which angle has a slope ratio of 10? So it tells you, if you refer back to that document, you will see, actually I have it here, so let's go back and look. 4.1.3, if you look over here, who has a slope ratio of 10? Right here, 84 degrees. All right, so I know then my Leaning Tower of Pisa is now leaning at 84 degrees. So it is slanting at 84 degrees, right? Is it in immediate danger of collapse? Well, it's be less than 83 to be collapsing, so no. So not in immediate danger. Of course, there are other factors, but right now we're just saying just the angle. Is it in danger of falling? Okay. All right, solve for the variables in the triangles below. Use your trig table for reference. All right, so it's a little bit tilted. You have to kind of turn your paper sideways to look at these things. Okay, so first things first, there's a couple of things we're solving for here. So make sure we do that. Let's see. First thing we're solving for, I'm going to solve for the angle, this theta right here. Well, if I know that a triangle adds up to 180, then I have 90, I have 79. So in this case, if I subtract 180 and I subtract 90, subtract 79, I will get 11 degrees. All right, 11 degrees. Okay, so now because you have two angles, you can look at this in two different ways. You can use 11 degrees. If you use 11 degrees, then your rise is here and your run is here. Okay? If you use 79 degrees, you got to turn yourself sideways and now look at it as this is the rise and this is the run. So it doesn't matter which one you choose. Choose the one that suits you best. In fact, our table has both values, so it really depends on what you want to do. Okay? All right, so for me, I'm just gonna go with 11 degrees because for me, the way my iPad is situated, it's a little bit easier to see the rise over run. All right, so if I look at 11 degrees and going back to my chart, 11 degrees has a really nice ratio of 1 over 5. So 1 over 5. And now let's look at my problem. My rise is W, my run is 12. Okay. All right, now I'm going to cross multiply and see if I can solve for W. So I get 12 times 1 is 12 equals 5 times W, 5W. Divide by 5 on both sides. W equals 2.4. All right, so my W is 2.4. I think that's it, right? Solve for the variables in the triangle below. I solve for both different variables. I solve for the theta, I solve for the W, and I'm done. Okay. All right. Same thing in the next one. You have two things you're solving for. You're solving for the theta. So you know this is 22 degrees here and this is 90 degrees here. What's the last angle here? So theta must be 68 degrees to make 180 degrees. Okay, so now you have, again, options. You can figure out which one do you want to use in terms of how to see your rise over run. So for me, it may be easier to look at this angle, the 68 degrees, because then I can see that this is my rise and this is my run, right? 8 over z. Okay, so then I look at my chart, 68 degrees, the ratio is 5 over 2, so 5 over 2 is equal to, the problem here, I have 8 over z. Okay, all right, there's no multiplication to do here, so I'm just going to cross multiply again. I have 5z equals 2 times 8, 5z equals 16, z, so if I divide by 5 on both sides, I get 3.2. Z is equal to 3.2, okay? All right. Next, I am looking at another angle here. All right, so I have two variables again. I have a theta and I have an x. Okay, so theta, same method as before. I'm going to look at it and say, okay, I got 18 degrees, I got 90 degrees. What else do I need? I need 72 degrees. Sometimes my math is not so good when it's late in the evening. So sorry, it does take a little bit more time. Okay. All right. Now I have both angles here, right? Again, you can figure out which one you want to use. It may require you to turn your head a little bit. So for me, again, the way my computer is situated, it may be easier to look at that angle and then see that the rise and the run is this way. So 15 over x. All right. So now I look at my chart and say, all right, 72 degrees, the ratio is 3 over 1. So then my rise over run is 15 over x. Oh, this one's nice because this one I can see the multiplication. I can go 3 times 5 times 5. So in this case, I can very, very nicely say x equals 5. And be done with that ratio. Okay? All right, so that's the front page. Let's continue on to the second page. So look at the triangle at the right. Can you rotate the triangle so that 18 degrees look like a slope angle and then solve for A? So you may want to turn your paper sideways, right? Turn your paper sideways and then see the fact that this is your rise and this is your run, right? If you turn sideways and make 18 degrees right here, right? Have A on the flat side. Okay, so can you rotate triangle? Yes, you can, and then solve for A. So 18 degrees, let's look at our ratio. 18 degrees, 1 over 3. And then if I look at this problem, the rise over run is 4 over A. Okay, and now let's cross multiply. I get A times 1 is A equals 3 times 4 is 12. So A equals 12. Okay, I solve for A. Very nice. So can you tell rise? Can you tell your delta y equals 4 without turning your triangle? How can you do that? So if I don't turn my triangle, how do I know which one is my rise? Which one's the delta y? So here's a nice little trick. The way you look at it is, this is how I usually tell students, the way you look at it is, look at your 18 degrees, right? Who is touching your 18 degrees? This side and this side is touching your 18 degrees. The only side that doesn't touch your 18 degrees is the 4. So that side is what we call the opposite. It is opposite. It is directly opposite of the 18 degrees. You will never touch the angle. All right. So you can talk about the fact that it is the opposite side of the 18 degrees, or is the only side not touching 18 degrees. So that may be helpful because we can't always turn our paper, right? So if we cannot turn our paper, how do we know which one's the rise, which one's the run, which one's the delta y, delta x, so we can set up our proportions correctly? Okay. What if we use 72 degrees as our slope angle? Oh, okay, so let's clear this up. Where is 72 degrees? Well, 72 degrees is this missing angle right here. That's 72 degrees. So now this requires a little bit more work to look at which one is your rise and which one's your run. So you need to kind of turn this, you got to rotate this, you got to reflect it. So let me see if I can help you see this picture. If you were to use 72 degrees, you actually have to turn your triangle this way. And this is where your 72 degrees is. This is your 4, this is your A, this is your 90, and this is your 18. So again, hopefully you see this is the same triangle but reflected. I turn it around and now I can see what's my rise and what's my run, right? My delta y and delta x. So what's different this time? Well, my delta y, my rise is actually A, and my delta x is 4. It's exact opposite of 18 degrees. If I were using 18 degrees, my delta y will be 4, and then my delta x would be A, right? So what changes? The delta x and delta y switched. They switched roles, right? All right. Confirm your answer to part C. So we want to make sure we are right. That's what it means, confirm. All right. So what we want to do is then, okay, we use 72 degrees as our angle. So our slope angle is 72 degrees using our chart from the previous section. The ratio for 72 degrees is 3 over 1. So for 72 degrees, the slope ratio is 3 over 1, okay? And then in my problem here, my rise is A, my run is 4. Okay, so then I'm going to cross multiply and get 3 times 4 is 12 equals 8 times 1 is 8. 12 equals A. So yes, It's the same thing. We get the same exact answer as part A. So that way our method works, and we know that we can switch our triangle. We can use a different angle in the triangle and still get the same answer, even though the ratio is a little bit different. Okay. All right, you need your calculators. You need a scientific calculator. So I've been relying on my phone here. If you are relying on your phone for the notes, you might want to just turn it sideways. That's where it gives you the scientific part. We want the scientific part because we want to use the tangent, sine, cosine, tangent stuff. So don't worry too much about that. Let's see. According to the triangle on the right, what is the slope ratio for 32 degrees? So if we look at this triangle here to the right, here is 32 degrees. So based on that, my rise is 5, my run is 8. So based on this, the slope ratio will be 5 over 8. Okay, what we want you to do is go ahead and put that in the calculator, 5 divided by 8, because it's really good to know the decimal of it too. Okay, it'll be handy later. What about the other way around? What is the slope ratio of 58 degrees? Hint. It's really, really similar to what we just did. Okay, so if you already know what to do, fantastic. If not, let's take a look. If we're now on 58 degrees, my rise is 8, my run is 5. So the slope ratio is 8 over 5, right? It is the opposite, or actually not opposite, it's not called opposite. The correct term is, this is the reciprocal of 32 degrees slope ratio, right? It's the same fraction, but reciprocal, right? How do you know? Because 58 degrees is complementary. Hint, remember that word? Complementary to 32 degrees. Remind yourself again, what does complementary mean? Complementary means that the two angles add up to 90 degrees. So if the two angles add up to 90 degrees, then their slope ratios are reciprocals of each other. Does that maybe have something to do with the fact that 90 degrees are also perpendicular and the slopes are opposite reciprocals? Something like that. All right, so something like that. Use the tan button on your calculator to verify that you get ratios you get the ratios you get for part A and part B. This is why I say you want to use calculator. You do want to change this 8 over 5 to a decimal. So 8 over 5 is 1.6. Okay, so now you want to use your scientific calculator. You want to punch in tangent of 32 degrees, and you want to punch in tangent of 58 degrees. I want, first of all, check my mode. I need to be in degrees. All right, so if you're using a graphing calculator like me, make sure you check your mode and change it to the right mode. You want to be in degrees, all right? So you want to punch tangent 32, okay? And then tangent of 58. Okay, so my first answer, if you round to 3 decimal places, 0.625, and the second answer is 1.6. I remember this was about 0.625, and this is about 1.6, right? Because it goes on and on and on. So let's check with our decimals. Perfect, right? It matched our answer for the 32 degrees, and it matched our answer for 58 degrees. So that's what the tangent button does for you on a calculator. The tangent button gives you the slope ratio in decimal form, obviously, not in fraction form, but it gives it to you in decimal form. So now you're not restricted to just the tangent table that you have in from your notes 4.1.3, but you can have all the angles, any angle, even decimal angles, because your calculator has stored all that information in that tangent button. So that's amazing, because now you open up a whole world of opportunities. Okay. All right. So let's see. Label the triangle legs below as delta x and delta y. So this is my rise. This is my run based on the given slope angle. Then write the equation using a scientific calculator to find the slope ratio for the given angle and solve for x. Okay, so first thing I want to do is I want to take a look at the fact that this is 38 degrees. So 38 degrees, right? And the ratio is rise over run. So the ratio is x over 8. But what ratio is this? This rise over run ratio is called the tangent ratio. So tangent of 38 equals x over 8. Okay, so tangent of 38 equals x over 8. So this whole thing is a number. You are going to punch in a calculator in a minute, but not right away, right? Because I don't want you to do that until the very end. Remind yourself, if you were to solve for x, what's your next step? You want to get rid of that 8. So you multiply both sides by 8. So that will get rid of the 8. So now your left side is really 8 times tangent of 38. That's when I want to punch it in the calculator. Now, if you're not using a graphing calculator, some scientific calculators need you to punch it in backwards. Some scientific calculator needs you to punch 38, then tangent, then times, then 8. Right, so completely backwards. If you're using a graphing calculator, you can just punch in what you see, which is 8 times tangent 38. So I'm going to try using my phone now. My phone is the one that goes backwards. So my phone goes 38, and I push the button tangent, and I push times, and I push 8. So my final answer should be x is about, because you can see it's a lot of decimals, 6.25. And that should be my final answer. Okay. All right, so if you're not getting the answer, please talk to me during office hours or in class. Let me know that you're not getting this answer, because most likely you're in the wrong mode, and I can help you see how to fix your mode. Everybody has a different calculator, so it's very hard for me to address all the different issues. So make sure you talk to me or Mrs. Waldwin, depending on who you have, and talk to us and tell us if you're having trouble getting the exact same answer, because it's usually a very quick fix. Okay. All right. Next one, the 73 degrees, you might have to kind of turn your head sideways and kind of turn upside down. But if you do that, you will see that your rise is 9, your run is x, right? So I know that my rise over run is like that. Remember, we're using tangent. Tangent allows us to use rise over run. So tangent of the angle is 73 degrees. Now the 9's on top and the x is on the bottom. What do we do? So if you didn't know this trick yet, this is a very handy trick to do. If your variable is in the bottom of the denominator, you can simply take the left side and that denominator and switch places. So it becomes x equals 9 divided by tangent of 73. Cool, huh? All right, now you can punch out in a calculator. So if you're using a scientific calculator, this gets tricky. So what should you do? So if you're using a scientific calculator, you kind of need to do it backwards, but not completely. You punch 9, you punch divide, but then you punch 73, tangent, and then equal, and then equal again. So let's try this again. All right, so 9 divide 73, punch the tangent, equal, and then equal once more. Because when you do that, the first equal gives you the tangent of 73, the second equal makes it divide by the 9. So you get a really funky answer, and I don't think I am right. So let's see. I have 9 divided by 73 tangent equal. All right, never mind, just one equal. So just one equal would be good. If you do 2 equal, it's really not the best. So my calculator did it where when I punched this tangent, it already did the tangent of 73. That's why you don't need a second equal. Some calculators do, so you do need to try and see which one is yours. Some do need a 2 equal, so give it a couple of punches and see. Okay. All right. Last one here, you have 45 degrees here. If you want, you could solve for this one and say, hey, this is also 45 degrees. So you can use either way. It really doesn't matter. And if you know already the answer, don't steal my thunder, you know what to do. But if you take a look at this 45 degrees, you will see that, okay, if I set up a tangent of 45 degrees and I have my rise over run, so I have 14 over x. All right, so same as before, Ms. Chu says the x is on the bottom. I'm going to swap the whole thing around. So x equals 14 over tangent of 45. All right, this time I'm going to punch it in right. So 14 divided by 45, tangent equal. Wait a minute, Ms. Chu, it says 14. It should be, right? 45, 45, 90. We said that if the angles are the same, the sides are the same. So if there's 14 here, x is also 14. That's why I said if you already know the answer, don't steal the thunder. So you probably already saw that. Okay. All right. So this is really helping you see all the different ways that the tangent button on the calculator is really going to be helpful for you, because we don't have the information for 38 degrees and 73 degrees. On our table here, we have, I believe, we don't have anything in the 30s. We have 72 degrees. So one degree makes a huge difference in the slope ratio. And so that's why your calculator is going to be super helpful for you. Okay. All right. If you take a quick look here, make sure you just read through here. It just kind of further affirms the whole tangent ratio, which one's a rise, which one's a run, depending on where your angle is, which one's your opposite, which one's your adjacent. Opposite is always the side that's not touching the angle, and adjacent is the one that's touching the angle but is not the hypotenuse. So this is why you always need to put in the hypotenuse first, and then you can see which one's the opposite and adjacent. Okay, don't worry if this is still kind of iffy, because we'll definitely go through this concept more and more. Okay, all right guys, that's it.